Welcome back to another video. In this video, we're going to talk about how to add and subtract fractions, okay? So one thing you have to know is that whenever you want to add and subtract fractions, you have to make sure that both fractions have the same denominator before you can even add and subtract them. Okay, so that means you have to go through a process of what's called finding the least common denominator. Okay, so you want to find the least common denominator. That means you want to find a number that you can make both of those denominators have, so that they'll have the same denominator. Once they have the same denominator, then you can combine those fractions by either subtracting or adding the numerator and keeping that same denominator. So let's go through this process by working a few examples. For this first example, we want to add 1/2 plus 2/5. So notice that these fractions have different denominators. So remember, the number in the top is called the numerator, the number in the bottom is called the denominator. The denominators are different. If they're different, we cannot add these, so we need to make them the same. Well, how do you make them the same? Well, you have to go through and find all of the multiples, well, not all of them, but some multiples of the denominator. So 2 and 5 are my denominators. I want to find multiples of 2. So 2, 4, 6, 8, 10, 12. You can keep going, right? Then I want to find multiples of 5. 5, 10, 15, 20, 25, and you can keep going. However, I'm looking for the one that they have in common. That's the smallest. So they might have multiple in common, but I want the smallest one. That's why it's called the least common denominator. So if I look, and it's good to start with the bigger number. 5, do they have 5 in common? No. 10, do they have 10 in common? Well, yes, they have 10 in common. So that means my least common denominator, which I'm going to call the LCD, is equal to 10. Once I know the least common denominator, then I want to go through and I want to make each of these fractions have a denominator of 10. So I want to start with 1/2, and the goal is to make 1/2 have a denominator of 10. So I want to ask myself, 2 times what will give me 10? 2 times 5 will give me 10. So if I want to get 10 in the denominator, I have to multiply 2 by 5. But I can't just multiply 2 by 5. I have to multiply the top and bottom by 5. Now, why do I have to multiply the top and bottom by 5? Because 5 over 5 is equal to 1. And 1/2 times 1 is still equal to 1/2. That means if I multiply the top and bottom by the same number, then I'm not changing this fraction. I'm not changing what it's equivalent to. Only thing I'm changing is the form that it's written in. So if I multiply 1 times 5, I get 5. So in other words, 1/2 is equal to 5/10, meaning this is still equal to this. It's just written in a different form. So I'm going to replace 1/2 with 5/10. Okay. My next fraction is 2/5, and I want to make 2/5 have a denominator of 10 also. So then the next question is, 5 times what will give me 10? Well, 5 times 2. And whatever I multiply the denominator by, I also have to multiply the numerator by. So 2 times 2 is 4, and 5 times 2 is 10. So 2/5 is equivalent to 4/10. So I'm going to replace 2/5 with 4/10. So I've rewritten 1/2 so that it has a denominator of 10, and I've rewritten 2/5 so that it has a denominator of 10. They now both have the same denominator, so I can combine those by adding the numerators and keeping the denominator the same. So 5 plus 4, which is 9, and that is over 10. So 9 over 10 is the solution to that problem. So that's how you go through the process of finding a LCD, a least common denominator, making both fractions have that LCD, and then combining those fractions. So let's look at another example. In example 2, we want to add 3/4 plus 2/3. So if you look at these, you see that the denominators are different. So we need to find a common denominator, a least common denominator, the LCD. So we want to take multiples of 4 and multiples of 3 and see what is the smallest one they have in common. So if I list some multiples of 4, 4, 8, 12, 16, 20, and I can keep going if I need to. Multiples of 3, 3, 6, 9, 12, 15, 18, and I can keep going if I need to. But if I start with the biggest number, 4, they don't have in common. 8, they don't have in common. 12, they do have in common. So 12 is the least common denominator. So I want to make both of these fractions have a denominator of 12. So I'm going to start with 3/4. I need to figure out what do I need to multiply 4 by in order to make it have a denominator of 12. Well, I need to multiply 4 by 3. 4 times 3 is 12. And whatever I multiply the denominator by, I also have to multiply the numerator by. So 3 times 3 is 9. So 3/4 is equivalent to 9 over 12. So I'm going to come up here and I'm going to replace 3/4 with 9 over 12. And then I'll go through that same process with 2/3. So 2 over 3, I need to figure out what do I multiply 3 by in order to get 12 in the denominator. Well, 3 times 4. 3 times 4 is 12. Whatever I multiply the denominator by, I also have to multiply the numerator by. So 2 times 4 is 8. So 2 over 3 is equivalent to 8 over 12. So I'm going to replace 2/3 with 8/12. So now my denominators are the same. So now I can actually combine the numerators by adding them together and keep that same denominator. So 9 plus 8 is 17. So this actually ends up being 17 over 12, which is an improper fraction. There's nothing wrong with leaving it like that, but you could also write that as a mixed number as 1 5/12. So that's how you would add those. Let's look at another example. For example 3, we want to do 5/6 minus 1/2. This one is actually a subtraction problem, but it works the same way as the other examples. You still cannot combine those if the denominators are not the same. So you have to go through and make the denominators the same. So my denominators are 6 and 2. So if I write some multiples of 6 and some multiples of 2, you know, it don't take many. But I noticed that the smallest that they have in common is 6, okay? So you just keep going until you find one that they have in common and the smallest that they have in common. So that means I want to make both of these denominators have a denominator of 6 because that's my LCD. However, this first one already has a denominator of 6, so that one I will keep it the same. It's the second one that I will need to go. It's the second fraction that I would need to go and convert it to have a denominator of 6. So I would ask myself, 2 times what will give me 6? 2 times 3 will give me 6. So whatever I multiply the denominator by, I also have to multiply the numerator by. So 1 times 3 is 3. So 1/2 is equivalent to 3/6. So I will replace 1/2 with 3/6. Now since the denominators are the same, I can actually combine the numerator and the denominator. Or not the numerator and the denominator. Combine the numerators by subtracting, and then the denominator would stay the same. So 5 minus 3 is 2, so this would become 2 over 6. And 2 over 6 can be reduced. 2 goes into both of those. 2 goes into 2 one time. So if I was to divide top and bottom by 2, that would be 1 over 3. 1/3 would be the final answer. Okay, this is the very last thing. I want you to try this example on your own. So just take a moment, pause the video, see if you can work this out and see what you get. Alrighty, did you get 13 over 24 as your answer? If you did, then you're good to go. Thanks for watching this video and thanks for tuning in. If this video helped you in any kind of way, make sure you hit the like button. And if you haven't already, hit the subscribe button. Now, if you did not get that answer, then just hold on for a minute. I'll walk you through how you got it. But I'll see you in the next video if you got the correct answer. Now, if you didn't get the correct answer, let's go through it. Our denominators are not the same, so we have to make them the same. So I have to look at multiples of 8, 16, 24, 32. Look at multiples of 12. 12, 24, 36. I already see the smallest one they have in common, which is 24. So now I need to make both of these fractions have a denominator of 24. So if I start with 1/8, then I ask myself 8 times what will give me 24? Well, 8 times 3 will give me 24. And so whatever I multiply the denominator by, I also have to multiply the numerator by. So that becomes 1 times 3, which is 3. So 1/8 is equivalent to 3 over 24. So I'm just going to erase this 13 over 24 first. And I'm going to rewrite 1/8 as 3 over 24. Now I need to make 5 over 12 have a denominator of 24. So the question is 12 times what will give me 24? 12 times 2. And so whatever I multiply the denominator by, I also have to multiply the numerator by. So 5 times 2 is 10. So 5 twelfths is equivalent to 10 over 24. So I'm going to replace 5 twelfths with 10 over 24. So I end up with 3 over 24 plus 10 over 24. The denominators are the same. So I can add those numerators together. 3 plus 10. The denominator stays the same. And so that becomes 13 over 24. So that is how you get 13 over 24 as a solution. So hopefully you get it now. Hopefully you can catch where you made your error. If you have any questions whatsoever, feel free to put them in the comments below and I will respond. Thanks for tuning in. I'll see you in the next video.